Let's go through LeetCode 2524 maximum frequency score of a subarray. For this question, it gives us integer nums and k. And let's find the maximum frequency score of a subarray which has a size k. So what is a frequency score? It is for this kind of subarray, for example, the sum of the distinct value of the array raised to the power of their frequency. So, for example, 5, 4, 5, 7, 7, 4, 4, 7, 4, 4. The 4 appears three times. 5 appeared twice, and 7 appear once, right? So the frequency score is 4 to the power 3 plus 5 to the power 2 plus 7 power 1, right? So we want to return the maximum frequency score of a subarray of size k in nums. And you should maximal the value under the mod and not the actual value, right? So because the data is big, so we should mod it. So um, we know for size k, right? We want to find the maximal score, right, for every size k. It is a very classical fixed size sliding window problem, right? So every time we move this kind of k, right, and we calculate the frequency score, local frequency score called the current, and compare with the global result. And in the end, we return the final result, right? So the thing is that for this kind of sliding window, right, every time we have one element move from the right, right? For example, let's say 4, right? Initially, in this kind of window, it appears, for example, twice. Then there is another 4 moving, right? Entering. Then four to the power 2, it all goes to 4 power 3, right? So what we need is that we should remove this kind of older part and add in this kind of new part, right, to this frequency score. But there is some special corner case is that initially there is a number, for example, 17, right? It doesn't appear in this window. So it is not 17 to the power 0 because this one equals 1, right? It is actually, this is from 0 goes to 17 power 1s, right? So what we need is that we just have a 17 power 1 and do not minus 17 power 0, right? So this one, we should just um, minus 0, right? Or we just add in this, right? So this is on its right. So on its left, right? So for example, we have a number moving out of our sliding window, right? So we have, for example, 5 and initially appears 3 times, and now it goes to 2 times, right? So that then what we do is that we need get rid of old one, add the new one, right? So add the new one, it's possible some kind of number. For example, 11, it goes to 0, right? If it goes 0, it's not add 11 to the power 0, right? It is add 1, add 0, right? It's not add, because 11 power 0, it will be 1. So for this question, what we're thinking about is that we need to use a map to store the frequency of the numbers, right? So let's write the main part for this. And we'll talk about how to handle the power with mod and a bit later. So what we do is that for the main function is let's have int n equals nums of the length, right? So we know we need a map to store its frequency. Uh, we're going to have long. This is the frequency score inside the window called current, and we need a result, right? Which is a global result. So what we do is that for int I equals 0, I smaller than n, I plus plus, then we are going to have a map merge nums I and one integer dot sum. Okay. So we'll see on its right, the new frequency will be map get nums I, right? And on its right, its old frequency is new frequency minus one, right? So we know our current should equals plus equal to this kind of factor, right? But we need a mod, right? So it should be current plus how can we handle the mod? We'll write a mod function called a mod pop. Okay, I'll talk about this a bit later. So we'll be nums I and write a new frequency and mod. And we'll say if we cannot just write this one minus this, right? Because it is possible that old one is 0. So we should have a special cases to handle the 0, right? So we'll say if write old frequency doesn't equal to 0, then we are able to minus the old one, right? Mod pop nums I write old frequency and mod, right? But for this one, it is possible because we are minus something. It's possible it is going to negative. So we'll have a mod add. Okay. So this is on the right part, right? So let's say if I greater equal to k, we there is some element moving out of the left side. So we'll have map merge nums I minus k and one minus one, right? Because we're decreasing one frequency integer and sum. And we'll have int left new frequency equals map get nums I minus one. And int left right frequency equals left new frequency left old frequency, right? Should be this one plus one, right? So we'll say current equals, we should moving out the old one, right? Old one should always be positive because we are moving something out. So it will always be positive. So that means that we are going to have current minus mod power nums I minus k. Left old frequency, and we have this one mod, right? Because it is the subtract, it's possible this one will be negative, so we'll have mod plus. And we'll add a new one. If a new one is not going to 0, right? So I'll say if left new frequency down equal to 0, then we'll have current equals current plus mod power nums I minus k left new frequency mod, right? And if the new one equals to 0, we can move this one out of the map, right? So that we don't store too many things in the map. Remove nums I minus k. Okay. So here, if our window size is greater, the index is greater equal to I minus 1, right? We'll have result equals max result. And you can have this one pass mod to get it safe, right? Actually, we already for every current we have use a mod calculation, so we don't have this one should be fine. Current, here, right? Here we need a if I greater equal to I k minus 1, right? This condition because we this number may be very big, right? If it is monotonic increasing, and if we don't mod because before we have a complete window, it's possible we already have mod, so it is possibly a big number in the front, then decrease, right? So if the number is monotonic increasing, we didn't have model calculations, then we don't need I greater equal to k minus 1. But this one is another part easy to make a mistake because we have model operations. So it is possible when we calculate this part, this is already getting a very big number. So in the end, what we need is return that's my int results mod, right? So we talk about now. Let's talk about the private how to calculate mod, right? The power we call mod power. We call long expression. Right? So if we use a brute force to have, for example, for loop, right? For int I equals 0, I smaller than expression, right? And the base keeping multiple, it will be TLE because the number may be very big, right? So we know we should have something efficient. Oh, here the thing is that we can not write something like a mass power base expression, right? Because this may be out of the range for the loan, and also because mass power it will lose the accuracy, right? So we should do something better for this. So we know every number, for example, we have an x power a, right? We can write this a as its binary format. For example, 1, 0, 1, 1, 1 is 2, right? So if we know this write this one as its binary format, it will be then how can we calculate this one, right? We know for a number, if x to the power, this is binary format, is power 2 to the power n minus 1, right? And multiple by x to the power 2 to the power n minus 1, right? So this one equals, let's get rid of this. This one equals x to the power 2 multiplied by 2 to the power n minus 1, right? So this will be x power to the power n, right? So that means that um, if we know this kind of things multiplied by itself will be x power to the 2 power n, right? So what does this one mean? Is um is that when we write this expression in a binary format, for example, 10111, right? So we have a base for this one, right? So we just look at the bits from the lower to uh, to uh, um, to higher. So this will be base to the power 2 to the power 10111, right? So we know if there is a one, what we do is that we have our results, right? Should multiply by for example, we have base. We have keeping using the base multiply itself, right? Then that is the same effect as we move the digits from the lower to higher. So if there is a 1 here, then we have our result should multiply by equal to the base. Right? So if we know this, we can write mod power function easily. So that will have long result equals to 1. And so we convert this kind of expression, check the bits from the lowest to right to higher bits, right? So we'll have expression right shift 1 and right. So for this one, every time we should have base equal like this, right? But we need a mod, right? So what we do is that we have base multiple by base and use mod, right? So we'll say if this digit is not a zero, right? So if this digit is 1, then our result should multiple equal to our base, right? So that is actually equals result multiplied base and mod, right? And in the end, we return result. So result equals this one multiplied by base return. If that's equal to, let's still have current house mod. Trying to see if this one works because this should not exceed let's find you have this long result equals on to the hash map submerge to its right, and the right frequency will be this, and hold will be this, and new and not equal to 0, we minus greater equal to k. Result equals 1, while this one base equals base multiplied by base by shift. When this greater equal to k minus 1. Map minus minus. This is not a I minus 1, right? Should be minus k. Doing like this, right? We'll see this one, this kind of power amount of power, it will be some kind of log expression operation, right? And this kind of window is linear, right? So the space will be, because here this is a log expression time complexity for this kind of model operation. So the time complexity for this is O n log expression, right? So we need to have max expression, and the space will be O n, right? Let's write a Python code for this as well. So Python will be very similar. We'll say we're going to have we need a dictionary, right? So if we need dictionary, we need from collections import default pick. Okay. Then what we do is that we are going to have let's write mass power first, model power and base expression. So what we do is that we have result equals 1, while this expression down equal to 0. We have if this expression and 1, if this digits is 1, right? We'll have result equals result multiplied by base, and we need a mod here, right? Mod mod equals 1 mod. Then so for every digits, it is actually the base equals base multiplied by base um mod, right? And we have expression to the right shift by 1. And in the end, the return result. So this is the mod power function, right? So for our main function, let's have n and frequency map and current the window frequency score and result. So n equals length months, and this one will be default date and current equals to 0 and the global result equal to 0. So what do we do is that for I in range, and we're going to have frequency map nums I equals should increase by 1. Right? So write a new frequency equals frequency nums I and write old frequency equals write new frequency minus 1. Right? So our current equals current plus mod power nums I and write a new frequency mod. So I say if write all the frequency down equal to 0, we are going to have current equals mod plus current minus mod power nums I write all the frequency mod. So let's say if I greater equal to k, right? Then we'll have frequency map nums I minus k should decrease by 1. So let's say left new frequency equals the frequency map nums I minus k. And left right old frequency equals left new frequency plus 1, right? So we'll say current should equals we should minus the old one, right? Plus current minus mod power nums I minus k, and it's left all the frequency. Okay, right. So that means that if we left the new frequency down equal to 0, right? Then we'll have current equals current plus and mod power nums I minus k, and the left new frequency and mod, and else we move this one from the map. So let's say if I is greater equal to k minus 1, we're going to have result equals to max result current. And in the end, just return this as result amount, right? Where's frequency. Frequency. Where is that? Frequency here. 125.